Now the fifth example for friction clutch. So a plate clutch consists of a flat driven plate gripped between a driving plate and a pressure plate so that there are two active driving surfaces. So the N is equals to 2, the number of pair of contact surfaces. 2. Each having an inner 200 mm and an outer diameter of 350 millimeter. So the inner radius should be 100 millimeter. The outer radius should be 175, okay, millimeter. The coefficient of friction is 0.4, and working pressure is limited to 170 kilonewton per meter square. Now, assuming the pressure is uniform, so here, this question, they have stated that we have to refer to the uniform pressure, here. Okay, so that's the uniform pressure. Then calculate the power which can be transmitted at 1000 revolutions per minute. Now, if the clutch becomes worn, that means when it wears off, so that the intensity of pressure now is inversely proportional to the radius. So the second part of the question refers to uniform wear. Okay, the second part of the question refers to uniform wear. Initially, it is uniform pressure. Okay, initially it is the uniform pressure, and then after that becomes uniform wear. Now the total actual force on the pressure plate remaining unaltered. So that means once you calculate the actual spring force, which initially is under uniform pressure theory, okay, then when you apply uniform wear theory, the actual spring force would remain the same. So that means the W will be the same as for uniform pressure theory and then uniform wear theory. Now calculate the power which can now be transmitted at 1000 revolutions per minute and the greatest intensity pressure on the friction surfaces. So this is, okay, the clutch basically. Okay, so you have these are called the diaphragms. The yellow one is the pressure plate, and this is the clutch disc. Okay. Now, based on uniform pressure theory initially, okay, first we take uniform pressure theory. So, based on uniform pressure theory, since the pressure distribution on this surface here, is the same, so therefore we can apply force over area straight away. So based on this, because they have given us the pressure of 170 kilonewton per meter square, we will be able to find out the spring force, the actual spring force, which is useful when we assume uniform wear theory. Okay, so the pressure with the area. So this is the surface contact area of the disc clutch, which is given by this pi r1 square minus r2 square, which is the surface area of the friction lining material. So from here, you will be able to find the initial actual spring force. So which is 11.02 kilonewton. That is based on uniform pressure theory. Then you can apply this when you consider uniform wear theory. Okay, because they say the pressure plate, okay, the total actual force on the pressure plate remaining unchanged. So based on uniform pressure theory, so the torque formula is given as this. Okay, so what you need to do is substitute everything to find out the torque. Okay, so this your outer radius now. That is when you take this divided by 1000 and divided by 2, because given what is given is diameter and in millimeter. Okay, so this is the outer radius and this is the inner radius. So this is your actual spring force and the coefficient of friction. This number of pair of contact surface is 2. So you will be able to find out the torque of 1242 Newton meter. Then power transmitted under uniform pressure theory. We know that for rotary motions or for objects which is moving in circular path, power transmission usually is given by P times angular speed. So the angular speed which is in radians per second, but what they have given here is in RPM. So you multiply it with 2 pi because one cycle, the circumferential length of a circular object is 2 pi. Okay, then divided, one revolution is 2 pi radian. Okay, then you divide this by 60 because you are converting the minute here to seconds. Okay, so that will be your omega, actually angular speed in radians per second times the torque T. So the power would be equals to 130 kilowatt. That is under uniform pressure theory. Okay, so this is basically how it looks like, okay, your clutch assembly. So based on uniform wear theory, now that is the second part. We are going into the second part in the questions, which they say after a period of time, the clutch disc here wears off, okay, what? Okay, so therefore that is why we have to consider uniform wear theory for the second part. So this is a torque transmitted under uniform wear theory. So putting in the all the data here, so you will be able to calculate the torque, which is 1212.2 Newton meter. Then the power transmitted under uniform wear theory. Okay, this is where uniform wear theory. So sorry. So this is my mistake here. This is uniform wear theory. So you'll just take a note that on that. Okay. This is uniform wear. Okay, my mistake. Okay, based on uniform wear theory. Okay, so the power based on this torque here. So you will have power transmitted the power transmitted is 127 kilowatt. So, and we know that for uniform wear, if you want to find out the constant C, it would be equals to this formula here. The constant C for uniform wear, this is not for uniform pressure. So if you want to find the C, so we have 23.39 kilonewton per meter. Okay, and then that is the torque. So we know that P max R min, okay, for uniform wear theory, P max R min is equals to a constant C. So therefore the P max should be equals to 234 kilonewton per meter square. That is what the question asked. Okay. Thank you very much. Stay safe.